Hello, I'm Taylor Glenn with Team 12 Hybrid Wind and Solar Electric. This system combines wind and solar power to charge a battery bank that can have multiple loads drawn. The size and power output is designed for residential applications, and the power generated is displayed on the Node-RED server for the user to monitor. This is the component housing subsystem. It is designed to house the internal electrical components. It is made out of thin galvanized steel sheets and comprises of a top, handles, rain guards, and ventilation holes. The ventilation holes are designed to disperse hydrogen gas buildup from the battery's charging, and this housing is also IP13 rated, which means objects larger than 50 millimeters cannot enter the housing, and it is waterproof up to 60 degrees. On the inside of the housing, our electrical components will sit on a 3/16" aluminum sheet supported by 1-inch rubber pegs. All the components will be mounted using L-brackets.
This is an example of how the system can be hooked up. Right now we have one battery operating, and it's being fed power from a solar panel. And the way this works is power will come to the battery and charge the battery, and that power will then flow through a MOSFET that is being pulsed by the Raspberry Pi. That power will then flow through a shunt resistor, and the point of the shunt resistor is so we can measure current. Because if we know the voltage drop across a resistor and the resistance, we know the current going through it. And since it's connected in series with the battery, that's the same amount of current. So we know the voltage drop across the battery and the current going through it, we now know the power being supplied to the battery. Now, most of the calculations are going to be done on the Raspberry Pi. The Raspberry Pi is being fed data from an analog to digital converter, which detects the voltage drop across the shunt resistor. And inside the code, there's a couple control loops to make sure that the current doesn't get too high. It detects the voltages and calculates the power by multiplying the voltage times the current. And one of the best parts about this is on your phone, you're able to pull up an application that will show you the real-time power being supplied to the battery. So right now you can see the solar panels is supplying about 115 watts, and throughout the day that'll change, and you can have multiple sources hooked up to it and see multiple sources in real time.
Thank you for watching this presentation.